All right. So, guys, let me explain to you 30,000 foot level what we're doing today. And guys, this is actually going to require that we go back to mid-September in order to really make sense of this. So let me give you the big picture. What we're going to do is we're going to start by reviewing some of the ideas. And actually, Maddie, we talked about this. Guys, we're going to review some of the answers to these conclusion questions to make sure that you're okay with at least two big ideas. Then, guys, we're going to go back to September and we're going to remind ourselves about something that we learned. And then, guys, at that point, we've got three ideas that we need to talk about. Some of my better animation work coming your way. Then, guys, if you take your notes page and flip it over on the back, there is a table that will organize, because tables organize, right? There's a table that will organize everything that you just learned, and then we're going to call it a day. You guys ready to go? All right. So, guys, in order to get started, do this. Grab a hold of your periodic tables and remind yourselves what that heavy blue line means on your periodic table. So, guys, talk to the person next to you and remind them what that blue line separates. All right, we're done. It was really that simple. It separates the metals from the non-metals. So where are the metals, left or right? Metals are on the left, non-metals are on the right. Now, guys, watch my hands and review. So, guys, as we go from left to right, they get smaller, yes? Why do they get smaller? The nucleus gets stronger, more positive. Yeah? What do you mean? Oh, I have no idea. Frankly, this is breaking like 4 different copyright laws because you're not supposed to have a digital copy of this. And I stole it from some other high school teacher who posted it on their website. I have no idea. He was trying to teach, or she was trying to teach something. I just lifted it. So yeah, just pretend it's not there. I have no idea. I don't know what he was doing. Anyway, so guys, metals and non-metals, right? So you should know the answers to these 3 questions. Metals, big or small? Big. Are they strong or weak? Weak. So what do they do with electrons? Give them away. Then, guys, over here, we've got, sulfur too. Not a clue. So, guys, over here on the right, we've got the non-metals. They are small. They are strong, and they take in electrons. You guys good? That all makes sense? All right. So now, guys, this. Ready? The Wayback Machine. You guys remember that? Oh my gosh, that was forever ago. But guys, do this. Today we are talking about bonding. But guys, we already talked about bonding. When elements bond together, they make compounds. But now, guys, we can break this down even more tightly. Guys, how many different kinds of elements are there? What's over here? The metals. What's over here? So, guys, when we talk about elements, we are talking about the metals and the non-metals. But guys, when the metals and the non-metals bond together, they form compounds. And this you don't know, so let me tee this up for you. Guys, when we talk about compounds, we are going to talk about salts, we are going to talk about molecules, and we are going to talk about the metallics. So guys, that's the big idea for today. There are 3 kinds of compounds: salts, molecules, and metallics. And by understanding the differences between them, we will then figure out how they form, and that's going to be the end of our day. You guys ready? So when you think salt, think table salt. Okay? Guys, keep table salt in mind, like this stuff, when you think of salt. A great example is table salt, sodium chloride. When you guys think about molecules, think carbon dioxide, the stuff that we're spewing into our atmosphere and sort of creating a big fuzzy blanket that's warming things up. And then, guys, when you think about the metallics, think about brass, which is a combination of copper and zinc. So when we think salts, we're going to think table salt. When we think carbon dioxide, we're thinking molecules. And then, guys, when we think metallics, we're going to think brass. You guys good to go? All right. So, guys, this sets the stage for today. Grab your class notes, and here we go. So, guys, in order to get started, the first thing we need to do is grab Mickey Mouse taking a nap. And, guys, there are some terms that you need to know in order to think and talk intelligently about bonding. So, guys, just label them, fill them in. Here we go. So, the first thing you're going to do is draw two lines that connect the nuclei of these atoms. And guys, maybe we should talk. I think some of you see it, but just in case. Guys, what molecule is this? This is water. So guys, we've got a big oxygen, we've got two small hydrogens. Guys, this is a water molecule. Did you say ozone, Liam? It could be ozone, except for all the atoms would be the same size, but it actually does have the same structure as water. Yeah, it's interesting. We talk a lot. Ozone's a crazy molecule. The chemistry is really cool, but we do it in AP. So, you guys good on water? Now this, draw, and well, actually label this. Guys, these lines that you drew are what are called bond axes. Now, guys, do this. Strike an arc right there. What do arcs represent? Angles. This is what is called a bond angle. Then, guys, this is a little bit harder to see, but do this. This radius right here, sort of draw it in a little heavier. Guys, some of you are going, wait, we know what that is because we graphed all of it. So guys, if you're thinking right now that this is the atomic radius, it's actually not. This is what is called the covalent radius. Guys, when these atoms bond to form molecules, they deform a little bit. So this is what is called the covalent radius. Now, guys, this one's even a little bit harder to see, but now what you're going to do is you're going to draw sort of a heavier line that connects the two nuclei. This is what is called the bond length. But because you guys are smarter than the average bear, and because you know that the covalent radii are on our periodic tables, guys, you may as well flip over your periodic table and find it. See covalent radii? Look at where atomic radii is, the one that you graphed. And is it above it or below it? Isn't it above it? So guys, the covalent radii are on the periodic table, so maybe this isn't a stretch. Guys, if you want to calculate the bond length, what do you do? Just add the covalent radii. If you know the covalent radii of oxygen, and if you know the covalent radii of hydrogen, you add them up and it gives you the bond length. Guys, this is the way we write that scientifically. Bond length is equal to sexy E covalent radius. Do you guys know about sexy E from math? Yeah, it's actually the Greek letter sigma, from which we got the Arabic, well, actually the English letter S, which stands for sum, S-U-M, which means to add up. So guys, it's exactly what Adam said. The bond length is add up the covalent radii. So guys, that's it. That's all the secretarial stuff. You need to know bond axis. You need to know bond angle. You need to know covalent radii. You need to know bond length. And you need to know how to find the bond length by adding up the covalent radii. You guys good on that? We're good? Okay. So guys, let me explain to you then how the rest... Can I go off this slide? Because let me explain to you the way the rest of the day is going to go. So here's what we're going to do. We are going to do this. We are going to talk about salts, molecules, and metallic substances. But the way that we're going to do it is through the lens of the atom pairings that form these. So guys, check it out. We've got metals and we've got nonmetals. How many different ways can two things come together? 3. Metal to metal, non-metal to non-metal, and then metal to non-metal. Guys, that's it. We've got 3 different compounds, salts, molecules, and metallics, and we've got 3 different possible ways these can come together. Guess what? That's how we're going to look at this. Guys, we're going to talk about what happens when a metal gets with a non-metal. Then what happens when a non-metal gets with a metal or a non-metal, and then what happens when a metal gets with a metal. But because we know the metals are big and fat and weak and the non-metals are small and strong, we're going to predict what's going on. You guys ready for the thoughts? Goes like this. So guys, do not write any of this down. It's not in your notes, right? No. Okay. So guys, fundamentally here's the deal. What is a chemical bond? It is an attractive force that brings atoms together to form molecules. How does it form? It is an attraction between the valence electrons, remember the highest S and P, that forms attractive forces between the atoms. Now guys, this can happen in one of 3 ways. We can go metal to non-metal, we can go non-metal to non-metal, and we can go metal to metal. And you're going to find out this forms the 3 different possible kinds of compounds. You guys ready? Here we go. First we're going to go, that's too dark. I'll just do it when the animation comes on. So guys, this is in your notes. First thing we're going to do is a metal with a non-metal. So guys, what are the chemical properties of metals? This isn't in your notes, but let's review. Big or small? Metals, big and weak. And then guys, the non-metals are small and strong. So guys, we're not going to talk about atoms. We're going to talk about playgrounds. 2nd grade, when that small, strong, strangely muscular 6-year-old comes over to the big, dumpy, weak kid on the playground. Guys, what happens when a kid that's really small and strong approaches a kid that's really weak, wanting what the weak kid has? It doesn't turn into a fight, does it? The weak kid gets his butt kicked and the strong kid steals his lunch. But then, guys, the weak kid is attracted to the strong kid because the weak kid wants his lunch back, but the strong kid's got it, and that creates attraction. Sad but true. Guys, the same thing goes on with atoms, and it goes like this. When these things react together, we get what are called ionic bonds. So an ionic bond is a strong non-metal stealing electrons from a weak metal. Did you like the lunch analogy? So guys, when this happens, ions form. The non-metal steals the electron. The metal loses an electron. These form ions, and these ions then attract each other, and they form a salt. Now guys, here's the problem. In your world, salt simply means NaCl. But guys, there are thousands and thousands of salts. NaCl is one of them, but guys, salt is a complete class of compounds. So what is a salt? It's simply a compound that contains ionic bonds. You guys ready to see it live and in action? This one's not bad. Wait until you see the metals one. It's a real doozy. All right, so guys, here we go. We're going to go over on the left-hand side of the periodic table, and we're going to grab a lithium atom. Lithium has got 1 valence electron, just like all the rest of the alkali metals. Then, guys, we're going to grab a non-metal, specifically the halogen fluorine. So guys, fluorine on the right is small and strong. Lithium on the left is big and fat and weak. So what's the fluorine going to do to the lithium? Steal, yeah, and guys watch, this is pretty good. The electron moves, huh? Oh yeah. The electron moves to the fluorine. So guys, this lithium lost an electron. What does its charge become? Positive or negative? Positive. This becomes negative. So +1 and -1, huh? Attract each other. And we just formed lithium fluoride, which is a salt. You get the idea? You now understand ionic bonding and salts. Not too bad? Not too bad. Questions there? Okay, yeah. So, it's a salt. I have some over in lab. We don't use it a lot. Even in AP, we don't use it much. Most salts are white. And they're crystalline. They're all crystalline, but most of them are white. Some of them aren't. But it's literally just a white crystalline salt made of lithium and fluoride. The one you might be more familiar with is actually, instead of lithium, if we did this with sodium, we would have sodium fluoride, and they actually put that in your toothpaste. I don't know, when you brush your teeth tonight, look at it. So sodium fluoride we use in toothpaste. The reason is because fluorine, remember, is the most electronegative element on the periodic table. And so what fluorine does is it grabs a hold of the atoms that make up the enamel in your teeth, and it grabs a hold of those atoms and locks them together so tightly, because it's so strong, it locks them together so tightly that it's hard for bacteria to get in there, and it keeps you from getting cavities. It's also the way they make non-stick pans. So non-stick pans are actually made of a fluoride-containing compound, and the fluoride locks the surface of the pan so tightly together that stuff can't stick to it. Yeah, fluoride's a funny beast. It grabs a hold of it. There are actually acids made of fluoride that you can't even store in glass. They're so reactive that the only thing you can store them in is wax, because they actually use it to etch glass, and eventually it will eat through the glass, so you have to store them in wax containers. Yeah, pretty crazy. You guys good on ionic bonding? Guys, we're halfway done. We're almost done and we're just getting started. You guys okay? All right, so now guys, what about this? Non-metal with non-metal. The next thing in your list. So guys, let's answer the question again. What are the properties of non-metals? Big or small? Small, non-metals. Non-metals are small and therefore strong. So guys, the question then becomes, what is going to happen when two nonmetals react together? If they're both strong, what's going to take place? Well, guys, I have a great example for you. Have any of you ever worked at the nursery at church? If you have, I don't recommend that you do this because somebody could get hurt. But I've tried it and it actually works. So guys, what you want to do is you want to go into the nursery with like the 3- and 4-year-olds. And so guys, many people believe that the first words that a child will ever say are mommy and daddy. You understand that's not true, right? What's the first word a kid learns to say? Mine. Seriously, check it out. Mine, that's mine, that's mine, that's mine. And so guys, the way that this goes is if you've got two kids in the nursery, and if one of these kids has got a toy, it does not matter what that toy is. The minute this kid gets a toy, this kid wants the toy. And so this kid will approach the kid with the toy, and that kid's going to grab a hold of that toy and go, mine. Now guys, what if the other kid is strong enough that the other kid can't get it away? Well, they're both going to have a grab on the toy, right? And guys, seriously, try this. You can literally pick up one of those children and the other one will lift with him because they're both locked onto the toy. Guys, that's exactly what happens in covalent bonding. These atoms come together around electrons, and neither one is strong enough to win, so neither one of them lets go, and they end up locked together. Do you get the idea? Guys, it goes like this. What we're going to end up with is two possible results. We have equal sharing when the kids are the same strength, and then we're going to have unequal sharing. So guys, it goes like this. Covalent bonding, filling in your notes. Covalent bonding happens during the sharing of electrons. Now guys, this can happen equally or this can happen unequally. So guys, let's talk about first what is called nonpolar covalent bonding. So guys, you ready for a weird nursery analogy? Who is the only kid on the planet that another kid can share with perfectly equally? Their twin. Chasing the analogy maybe further than it should go. But guys, the only atom that another atom can share perfectly with is another one of those atoms. So guys, this happens when two atoms of the same non-metal get together. You'll notice that's in your notes. This creates equal sharing. And it then leads to what we call nonpolar molecules. So guys, check it out. Are you guys well here? Is it too dark to fill in blanks? You okay? All right, so guys, let's go back to the screen and let's figure this out. So now we've got a fluorine atom and we've got another fluorine atom. Exactly the same strengths, but remember they're both strong. So guys, watch close. What does this fluorine do to this fluorine? It goes, mine. And it tries to steal an electron. What does this fluorine do to this fluorine? Mine. And it tries to steal an electron. Now guys, which one is stronger? Neither one. And so what ends up happening is they both come together around that shared pair of electrons. But notice guys, this pair of electrons is exactly in the middle, which means that it is equal sharing. And this creates what we call a nonpolar difluoride molecule. Do you understand sharing and specifically equal sharing? Okay, so now let's look at polar covalent bonding. Guys, polar covalent bonding, again in your notes, happens when different nonmetals get together. Now guys, understand that they're still nonmetals, so they're both strong. But neither one is strong enough to steal. So they share. But now they share unequally. And guys, this creates dipoles. So guys, what is a dipole? It is the partial charge on a bond caused by unequal sharing. Now guys, here's what I want you to do. Where it says this sharing is unequal, and put little X's through those two bullets. You do not need to know this for this unit. Guys, I'm sort of planting a seed that we're going to water and bring to life after Christmas. So if you don't understand dipoles, that's totally fine. We're going to spend the better part of 2 days on them when we get back from Christmas. So guys, I'm just going to sprinkle this in for flavor right now. Don't worry about it. Bottom line is this. When this happens, this creates what are called polar molecules. Guys, we are stinking cruising. Here we go. So now we're going to go oxygen and we're going to go fluorine. So guys, look, is it maybe too dark? Look at your periodic tables. Find oxygen and fluorine. Which one's going to be stronger, the fluorine or the oxygen? Don't look at their electronegativities. You should know by the trends. Why fluorine? That's true. But guys, what if we had done something like nitrogen and oxygen? What's the trend? As you go to the right, they get stronger. So guys, fluorine is going to be stronger than oxygen. So guys, again, follow the laser. Here's how this goes down. Fluorine goes, mine. And it tries to grab an electron. And oxygen goes, mine. And it tries to get an electron. But guys, what do you notice about where the electrons are? Closer to the fluorine. Why? Stronger. So now, when these lock down, the fluorine really snuggles up to the electrons, but the oxygen is further away. Now guys, watch. These are electrons, so they're negative. And because these negative electrons are closer to the fluorine, that creates what we call a negative dipole. The other end is the positive dipole. And again, guys, don't worry about whether or not that makes sense. You just need to understand that fluorine is stronger, so the sharing is unequal, and this makes polar molecules. We'll sort this out later. We good there? Guys, we got one more to go. This one's some of my better work. So guys, we have done metal to nonmetal, salts. We've done nonmetal to nonmetal, molecules. Now guys, we've got to do metal to metal. So guys, what are the properties of the metals? They are big and they are weak. So guys, what is going to happen when you get a bunch of big, fat, weak metals together? And guys, this is cool. Check this out. So guys, here we have, this was hard. Watch. So guys, here we have a bunch of big, fat lithium atoms. And guys, what do lithium atoms do? Well, they're big and they're fat and they're weak, so they're going to give away electrons. How many electrons do you think they're going to give away? One, because they have one valence electron. And so literally, guys, watch, they do this. They all give their electrons away. But who takes them in? Nobody. Because there's no non-metal around to take in the electrons. So guys, what we end up with is a bunch of positive atoms because they lost electrons. And then there's just this ocean of negative charge, and these positive ions are literally swimming around in this ocean of negative charge. Guys, this is why metals conduct electricity. Electricity is just electrons, and it flows right through the ocean. Guys, this is why metals are shiny. Just like a mountain lake on a still day, light reflects off of the ocean. Guys, all of the properties that you know of metals is because of this. So guys, in the AP book, it actually represents it like this. The nuclei and what we call the sea of electrons. And guys, that's down at the very bottom of your page. That's all you need to know about the metallics. Oh wait, I'm sorry, it's at the top of the back page. Sorry. Guys, that's it. We're done. All we need to do is review. You ready for the review? Guys, I would really strongly encourage you to do this. This summary sheet is a lifesaver. So, guys, we are going to talk about, did I give these to you? The type of bond that's formed, how it's formed, what forms it, how it's formed, and then the properties of the substances. So, guys, let's start down here and let's talk about ionic bonding, which is stealing. So guys, you should know the answers to these. First of all, what atom pairing forms ionic bonds? Metal and a non-metal. Oh, I'm sorry, let's go down first. I forgot the way I animated this. Covalent and then metallic. My bad. So guys, ionic bonding is a metal and a nonmetal. How does it form? Stealing followed by attraction. We say it this way: electron transfer, stealing, which creates ions, which then attract. And guys, these form what we call salts. I gave you a couple examples. Sodium chloride, you know, calcium iodide. Guys, anytime you've got a metal and a nonmetal, you got a salt. Pick a metal, calcium. Pick a nonmetal, sulfur. Calcium sulfide, it's a salt. And then guys, finally this, you need to know that metals have ions in all their phases. This will be important next year. Salts do not conduct electricity because their ions are locked in place, and they have very high melting points. If you don't believe me, guys, go home tonight, take a saucepan, fill it up with table salt, and throw it on the stove. You cannot get it to melt at home. We can melt it in labs, but guys, you shouldn't have access to enough heat at home to get this to melt. Liam, you may have access. Didn't you make like a smelter or something like that? You bought one. You could melt salt. Maybe we should do that next Tuesday. Or maybe not. All right, then guys, covalent bonds. What atom pairings do this? Nonmetals. If they're the same nonmetal, it's nonpolar. If they're different nonmetals, it's polar. Zooming in to make this a little easier. Then guys, how do these form? They form by sharing. And they form molecules. We talked about the example carbon dioxide. Water is a molecule. Sugars, fats, proteins, all of those are molecules. James, I'm curious to know what you're looking at. We'll talk in a minute. You guys all good? So guys, you should have a problem with what just came up on the screen. So notice what we've said. So molecules are formed by nonmetals. But one of the examples I gave you is water. Is that where your eye was going, James? Oh. It's funny how curiosity and exhaustion sort of look the same. Guys, do you see the problem with water? Find hydrogen on the periodic table. Which side is it on? The metals side. Guys, when we talk about this idea of molecules forming between nonmetals, hydrogen is the one exception to the rule. Hydrogen is a ridiculously strong metal. The reason is because it doesn't have any shielding, and as a result, that proton in the middle of hydrogen grabs electrons really well. So guys, the one exception to this rule is hydrogen. Hydrogen forms molecules and not salts because hydrogen is just freakishly strong. Then guys, this, molecules do not contain ions. They have low melting points. Go home tonight, grab some sugar, throw it in a saucepan, heat it up, it melts. Throw some butter in a saucepan, it melts. Where would you get pure protein? I don't know. It would melt too, though. I don't think protein powder would work. It'd be kind of fun to try. And then guys, solids do not conduct electricity, ever. They are insulators. You guys good? One last one to go and we're done. So guys, the metallics, what forms them? Metals. How do they form? This is the way we talk about this. Delocalized. It means without location, a delocalized sea of electrons around weak nuclei. If you just write down sea of electrons, you're going to be fine. And then guys, finally this, metals conduct. You know what, here, I could just write in what these mean. So they are ductile, which means, how do you spell stretch? How do we spell stretchy? Y or I-E? Y. They are stretchy. They are malleable, which means smushy. Or smooshy. Smushy. Don't mess with that, autocorrect. All right, here we go. Now you know the definitions. All right, so guys, metals conduct electricity. They are ductile, which means they stretch. Think taffy. They are malleable, which means if you hit them with a hammer, they smush without shattering. They're shiny because light bounces off the sea of electrons. And they also have high melting points. So guys, we're done. Dang, we killed it. So gang, homework assignment number 2 is next up on the hit parade. Guys, if you turn to assignment number 2, it is simply 2 pages long. As you fold your assignment open, you'll see them there. Guys, you're going to get your homework done today. Then please remember, when I see you on Wednesday, you're going to learn a skill and receive the last homework for the quarter. And then guys, Friday we will grade that last homework of the quarter. And then Friday, no new material. We are just going to reinforce what we did before. Then guys, next Tuesday, we don't know what we're going to do, but it might involve Liam melting salts or not. And then guys, Thursday, the Noble Metals Lab, because this is recording and I need to say that it's a lab. And then guys, Santa Claus is coming to town. We're going to make it. Things you need to keep in mind: Friday is the deadline for all late lab work and any late homework that you might have for the quarter. Remediation is today or tomorrow after school. And guys, that's it. That's us. Dig in. Let's get this homework done and call it a day.